All right, in this example, we're going to just get a deeper understanding of the math we're learning when we get to apply it to real life. When are you guys going to use this in real life? Right here. Here's an example. So Derek wants to order some roses online. For what number of roses is it less expensive to order from florist A? And honestly, that's the only question we're going to answer. We're not going to answer or from florist B. We'll just answer from florist A. So what this question is asking is going to guide how we set up our inequality. They want to know, when is florist A less expensive, so less than florist B. So we're going to put our florist A information on the left side of our inequality and our florist B information on the right side. So what do we know about florist A? They charge $4.75 per blue rose plus a $40 delivery charge. Okay. How many roses are we ordering? That's the question. For what number of roses? So our variable x will be representing the number of roses. So it costs $4.75 times every rose that gets ordered. In addition to that, we have a delivery charge of $40. You pay that just one time, so just plus 40 on the end. When is this, or how many roses does it take for this to be less expensive than florist B, who charges $5.15 per red rose plus a $25 delivery charge? So you can see they're more expensive per rose, but they don't charge as much for delivery. So that's why it's helpful for us to set up an inequality and solve to see when one will be less than the other. So $5.15 times every rose that we buy plus that one-time $25 charge. Here's the inequality. Now we're going to solve. Let's get our variables to the same side. I'm going to subtract $5.15 minus 5.15x. That's going to give me a negative 0.4x plus 40 is less than, carry down that 25. All right, we got a two-step equation. This plus 40 is going to the other side first. We're going to subtract 40 from both sides. So we have, I'm going to run out of room, negative 0.4x equals 25 minus 40 is, oh, not equals, oh, I caught it, is less than negative 15. All right, to get the x alone, we're going to divide both sides by negative 0.4. All right, so ding, ding, ding. We are dividing both sides by a negative 0.4. That is going to flip your inequality. So when I write x, instead of saying is less than, we're going to say is greater than, and we get 37.5. So what they're saying is that florist A will be less expensive when you order roses in a quantity greater than 37.5. And you can't order half of a rose, so you have to order at least 38 roses for company or florist A to be less expensive. Okay, so here that is written out. And you do need to write out our answer. Derek must order at least 38 roses for company, pretend that's a capital A, to be less expensive. That means he must order 38 roses or more. Okay, we have a follow-up question to answer. Derek still wants to order some roses online. Florist A charges $4.75 per blue rose plus a $40 delivery charge. So that information has not changed. Florist B charges $5.15 per red rose plus a $25 delivery charge. I guess that information is the same, but here's where we have some changes. If florist B increases the cost per rose to $5.20, so they went from $5.15 to $5.20, so a 5-cent increase. For what number of roses is it less expensive to order from florist A? And they also want us to do from florist B, but we'll just cross that off. Okay, so same idea. We want to know, when does florist A How many roses does it take for florist A to be less expensive than florist B? So we set up our florist A information. Florist A charges $4.75 per rose, which we're representing with an X, plus a $40 delivery charge. How many roses does it take for that to be less than florist B, which now charges $5.20 times every rose that is purchased, plus their delivery charge did not change, plus 25. Okay, let's solve this and see what we get. We have variables on both sides, so I'm going to get those to the same side by subtracting. I guess I'm choosing to subtracting the 5.20. 475x minus 5.20x is 0.45x, plus 40 is less than 25. Here's our two-step equation. We will have this solved in 2 steps by subtracting 40 from both sides. Oh, that is a negative 0.45. Oh, I'm struggling in this lesson. Your 40s cancel, so negative 0.45x is less than negative 15. Solve for x, we're going to divide both sides by a negative 0.45. What are we doing? Ding, 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 ding. We are dividing both sides by a negative number, so our x is, or our inequality, less than, is going to switch to a greater than. So here's what I'm talking about. This less than switch to a greater than. Negative 15 divided by negative 0.45. That does turn positive, and you get a 33.3 repeating on this one. So I'm just going to leave it as 33.3 because my answer is actually going to use a 34, and I'll tell you why. So what we figured out is the number of roses has to be greater than 33.3 repeating in order for company A to be less expensive. Maybe I'll phrase it that way. So you can't order 33.3 roses, so you have to order more than that. So we're going to bump that up to 34 when we write out our answer. Okay, so here's that answer written out. Derek needs to order at least 34 roses in order for company A to be less expensive. That means he must order 34 roses or more. And we're done with lesson 1.5.